All right, section 5, solving two-step equations. Let's go. So first vocabulary is two-step equations. That's really the main part of this. So a two-step equation is an equation that contains two operators in order to find the solution. So far we've only taken, add, subtract, multiply, or divide. We've only done one thing. So now we're going to actually have a second step in order to make this happen. So an example, you'll need to use addition to undo a subtraction, and then division to undo a multiplication in order to find the solution. A lot of words there. Let's see what it actually looks like. Okay, so here is a two-step equation. So a two-step equation. So let's take 2x minus 9. Let's start with that. Make sure this is on the right thing here. All right, colors, there we go. All right, so let's make sure 2x plus 1 equals 9. So we're going to start with that. It takes two steps. So we can look at it here as like there's an addition, so I'm going to have to use subtraction. There's a multiplication here, so I'm going to have to use divide. I always say do the addition or subtraction first, because if you do division, you'll have to divide everything, and then it just gets ugly. So can you do it? Yes. Is it more difficult? Oh, yeah. So I always try to do the multiplication or division last. So you try to take all the terms away first, and then you finish with that. So when we go along. So first thing we do is take the opposite of, or the inverse of positive 1 would be a negative 1. So we subtract 1 from both sides. Those will cancel out. And then we have the next step. So now that we're left with 2x equals 8, we're going to take 2x. We're going to use division on both sides. Again, remember, I like to see these on both sides. I like that thing there. I want to see division symbols. Divide on both sides, and then our solution comes out to 4. And that's pretty much all we're doing today, just over and over and over. I am a huge fan of algebra tiles. Some people aren't as big a fan of them. I love them because, again, I'm a visual learner. It also gives you kind of a tactile thing, and we may even do something in class about these just because it seems to make things a little easier at this point. All right, so let's take the equation 2x plus 1 equals 9. Same thing we just did. So x's are in spheres like this, or rectangles. So they have 2 x's and 1 equals 9 ones. So that's how we would set this up. So in order to remove 1 to subtract, we'd actually remove one tile from each side of the mat. So we take this one away and one of these away. We'd literally just pull them off. So then we're left with 8 of these and 2 of these. So if we separate the remaining groups into 2 equal groups, I'd have 4 and 4 with 1 of each x. From here, I can say that x would equal 4. All right, let's try it. So solve this, check your solution. Yes, you have to check your solution. That's how the instructions said. Okay, so first we'd look at this. We'd write the equation. I'm going to have to take a subtraction and a divide here to get the inverse of this and the inverse of this. So first we're going to subtract 4 from both sides. Then we're going to simplify that to make it easier. We bring that down. Remember, I like working vertically, so I would have actually gone plus 4 and plus 4 here and done this number. So these would have ended up canceling. That comes down, and we'd have brought the 3x down as well. So that's, or we can simplify, as they say. From there, we're going to divide both sides by 3, because the inverse of multiplication is division. Divide by 3 comes out to 7. Solve that vertically now. So I'd say I would go plus 4, do my t, bring out 21, and 3x. I would just bring that straight down. Divide by 3. The 3's cancel out, bring my x down, equals positive, positive, so it's a positive number, and 7. Check your solution, put 7 back in. Comes out equal, it would have been 21 minus 4. They kind of skipped a step there, but that's all right. The solution is 7. All right, next example. Right when we start looking at it here, I know I'm going to have to do the inverse of this, so I'm going to have to subtract. Since this is division, we're going to have to multiply. So first we write the equation. We're going to subtract 8 from both sides. Simplify that down. Here's where it gets slightly more complicated. From here, they did it how I like it for once. Say, put the parentheses around them, multiply both by 5, then these two will cancel. 5 times negative 25 is a negative 25. Simplify it out, we're done. Check your solution, punch that back in just like it says, because that's what the instruction told us. Riddle me this, Batman. Explain how inverse operations can be used to solve a two-step equation. So it can be done by undoing each operation in reverse order. So you may not have gotten the reverse order, but if you put undo each operation, maybe to get x by itself, I'll take that. All right, here's a couple other ones here. Pause it, give it a shot. All right, top one says to check, so we will check. So 4x plus 3 equals 19. I'm going to have to subtract, then divide. Minus 3 minus 3 goes down to 16. Divide by 4. Divide by 4. X equals 4. Put my 4 back in. 4 times 4 plus 3 equals 19. All I did was bring this down here. 16 plus 3, 19 equals 19. Check. All right, let's do this one. So w minus 8, w over 6 equals negative 4, plus 8, plus 8. 4, cancel that out, equals w over 6. So we're going to have to multiply both sides by 6. By 6, those cancel. W equals 6 times 4 is 24. All right, the formula F equals 1.8C plus 32 can be used to convert Fahrenheit to Celsius, because we've all wanted to know how to do that, right? Yeah. Okay, solve the equation to find the equivalent Celsius temperature for the degree 59 degrees Fahrenheit. So we're going to write the equation, and all we've done is taken the Fahrenheit one and substituted it for F. From here, it's a two-step equation. So I'm going to subtract 32. Simplify that. Then I'm going to divide both sides by 1.8. Gives me 15C. And so 15 degrees Celsius would be my answer. Keeping going. All right, so from here, they're just trying to trick you here because now they've just made this a negative number, or a negative x, which really is technically negative 1x. So first we write the equation. I'm going to use the identity property to put that 1 in there. They like to use definition of subtraction. I'm okay with you do. From there, you can subtract 5 from both sides. Leaves me with negative 1x. Here's where it gets complicated. You're not done. If x has to be completely by itself, the negative symbol is still something attached to it. So we're going to divide both by negative 1 to get x by itself, so x equals negative 2. So the answer is negative 2. All right, pause this, give it a shot. All right, so we're going to rewrite it first. 9 equals negative 4 minus m. So I'm going to plus 4 on both sides. These cancel. 4 to the is 13 equals negative m. Not done yet, but I'm going to divide by negative 1. Divide by negative 1. So this is going to go to negative 13 equals m. All right, try to go quick through these last ones. All right, so first we write the equation. I can't undo everything, or there's actually things I can do before I do the two-step equation parts. So I actually look at this and go, can I do anything right now? Yes, I can combine like terms. So I'll combine those identity property, put a 1 in front of the b by itself. We make it a negative 2b when I combine like terms of 1b and negative 3b. From here, I can subtract 8 from both sides. Now I'm going to have multiplication, so I'm going to have to use division to get it out. So divide by negative 2. And simplify, 10 divided by negative 2 is a negative 5. My answer is negative 5. You try. All right, so we'll do this one fairly quickly here. So I'm going to combine like terms first. So that's going to go to a 4x plus 13. Sorry, I went a little small here. Equals 9. From here, I can subtract 13 from both sides. That cancels. So that's going to go to negative 4 equals 4x. Divide by 4. That goes to a negative 1 equals x.